For tonight's video, you're taking your notes on that blue sheet of paper that I gave you in class today. All right, although mine isn't blue, just so that it projects better on white. So on the blue sheet of paper, the special right triangles paper that you received today in class, we're going to talk about two special right triangles, and hopefully you recall them from geometry class. Our first one is the 45-45 90-degree right triangle. And if this is our right angle, and our two acute angles of our right triangle are 45 degrees each, we have our 45-45 90-degree right triangle. What we're going to do is we're going to let each leg of our right triangle be equivalent to 1. All right? So if the length of each leg is 1, then what's the hypotenuse? Well, we can find it by using Pythagorean theorem. So if I simply off to the side do 1 squared plus 1 squared equals c squared, that's 2. So c squared equals 2. So c is equal to the square root of 2. So whenever you see a 45-45 90, you have to remember, okay, each leg is 1, and then the hypotenuse has a length, the square root of 2. Now, in relation to our 45-degree angle, it doesn't matter which one I choose. Let's suppose I'm working with this one. I'm looking at this one. All right. This one is the length of the side opposite. This one is the length of the side adjacent, and the square root of 2 is our hypotenuse. So now going back to our SOHCAHTOA, the sine of 45 is going to be opposite over hypotenuse. So the sine of 45 would be 1 over the square root of 2. Now let's rationalize that denominator by multiplying by 1 in the form of square root of 2 over square root of 2. And the result is the square root of 2 over 2. So the sine of 45 degrees is square root of 2 over 2. The cosine of 45 would be adjacent over hypotenuse. That would be 1 over the square root of 2 also, which, rationalizing the denominator, would result in the square root of 2 over 2. The tangent of 45-degree angle, tangent is opposite over adjacent, so that would be 1 over 1, which is 1. Now, cosecant, remember, is reciprocal of sine, so the cosecant is hypotenuse over opposite. So that would be the square root of 2 over 1, which is the square root of 2. The secant of 45, secant is the reciprocal of cosine, so that would be hypotenuse over adjacent, the square root of 2 over 1, which again is the square root of 2. And the cotangent of 45 would simply be the reciprocal of tangent, or adjacent over opposite, which is 1 over 1, which equals 1. Well, when are you going to have to know the sine of 45 degrees? When you're asked for the exact value, okay? If ever you are asked for the exact value, and you will be, the question will say, find the exact value of such and such an angle, right? And you can't use the calculator. Whenever the words state exact value, that's a U, you use your special right triangles. You use your special right triangles, or sometimes your unit circle, all right, if you're looking at quadrantal angle measures. Next triangle, special right triangle we're going to look at is the 30-60-90. So for this triangle, This angle appears to be much smaller than the other acute angle, so this will be our 30-degree angle, 60 and 90. Now in this right triangle, we'll let the shorter leg, the one opposite the smaller angle, the 30-degree angle, that is going to be represented with the length of 1. And if you recall from geometry last year, or whenever you did take geometry, if opposite the 30 is 1, the hypotenuse is twice that. So the hypotenuse would be 2. And opposite the 60 would be 1 square root of 3, which 1 times the square root of 3 is simply the square root of 3. So whenever you see a 30, 60, 90-degree triangle, basically what you're going to do is you're going to draw it yourself. You're going to draw 30, 60, 90, label it with the angle measures, and then opposite the 30, give it a length of 1, the hypotenuse a length of 2, and opposite the 60, the length of square root of 3. And other things that you have to memorize. Just like if we go back up to the 45, 45, 90, the two legs are going to be 1, and the hypotenuse is the square root of 2. Okay, so first we're going to give the exact value of these 6 trig functions for a 30-degree angle. So if I'm looking at my 30-degree angle, all right, in relation to the 30 degrees, the 1 is opposite. The hypotenuse doesn't change, that's going to be 2. And opposite the, adjacent to the 30 is the square root of 3. So now for the sine of 30, I'm going to use a green pen for this. For the sine of 30, that's going to be opposite over hypotenuse. That's 1 over 2, 1/2. The cosecant would be the reciprocal, 2 over 1, which is simply 2. The cosine of 30 is adjacent over hypotenuse, so that would be the square root of 3 over 2. The secant of 30 would be the reciprocal, 2 over the square root of 3. And yes, we'll have to rationalize that denominator to get this 2 square root of 3 over 3. The tangent of 30, that's opposite over adjacent. That'd be 1 over the square root of 3. Rationalize the denominator by multiplying by the square root of 3 over 3. I'm not showing that, but that's going to yield us square root of 3 over 3. And the cotangent of 30 would be the reciprocal of tangent, so that would be adjacent over opposite, so the square root of 3 over 1, which is equal to the square root of 3. And so just not to confuse us, I'm just going to go back and put this in green in relation to the 30-degree angle. This was opposite, and this was adjacent. Now, looking at the sine of 60 and the cosine and tangent, so the other 6 trig functions for a 60-degree angle. Okay, so now we're treating the 60-degree angle. We're looking at the 60-degree angle in reference to the 60. The square root of 3 is opposite, so let me just cross that off. Now this is opposite, and the leg of 1 here is adjacent. So now the sine of 60 is going to be opposite over hypotenuse, the square root of 3 over 2. The cosecant is the reciprocal, 2 over the square root of 3, which again, of course, we will rationalize, multiply by the square root of 3 over square root of 3, and we have 2 square root of 3 over 3. The cosine of 60, adjacent over hypotenuse, 1 over 2. The secant would be the reciprocal of that, or 2 over 1, which is equal to 2. The tangent of 60, tangent is opposite over adjacent, square root of 3 over 1, which is simply the square root of 3. And the cotangent of 60 would be the reciprocal of tangent, adjacent over opposite. 1 over the square root of 3. We rationalize the denominator, and we'll end up with the square root of 3 over 3. Okay, so if you're asked for the exact value of cosine of 60 degrees, you have to give it as the fraction 1/2. If you're asked for the exact value of the tangent of 60 degrees, you have to answer with the square root of 3. You cannot give a decimal equivalent. Now, let's look at this on the unit circle. So I have here an angle drawn in quadrant 1. All right. This actually divides the first quadrant in half. So this is a 45-degree angle that we have here. What are the coordinates of this point? Well, this is on the unit circle. So recall, if you have a point on the unit circle, the coordinates of that point, xy, again, as long as we are on the unit circle, right, which all of these are. This is our unit circle drawn here. The coordinates of a point on the unit circle, the x-coordinate is the cosine of our angle, theta, and the y-coordinate is the sine of our angle, theta. Remember this? So now if we want the coordinates of this point here of 45 degrees, we go up above, and cosine of theta, what was the cosine of our 45-degree angle? It was the square root of 2 over 2. And while we're here, the sine of 45 is the square root of 2 over 2. So the coordinates of this point would be square root of 2 over 2, comma, square root of 2 over 2. Now if we look at this as having symmetry here, this point here in quadrant 2, all right, would have the same values but with perhaps slightly different signs. By signs I mean SIG and S. All right. Our x-coordinate here is negative. So this would be negative square root of 2 over 2. And our y-coordinate, our y value is positive. That is the square root of 2 over 2. Now if we take this and put this down in the third quadrant, in quadrant 3, right, both our x and our y values are negative. So the coordinates of this point here on the unit circle would be negative square root of 2 over 2, comma, negative square root of 2 over 2. And then in quadrant 4, this point would have coordinates x value positive, so square root of 2 over 2, y value negative, negative square root of 2 over 2. So if we're in quadrant 1, the coordinates of the point on the unit circle with angle measured 45 degrees would be square root of 2 over 2, comma, square root of 2 over 2. Next, on our next unit circle, we're going to look at points on the unit circle with degree measures of 30 degrees. This point here in quadrant 1, again, since we're on the unit circle, goes cosine, sine. The cosine of 30 degrees is square root of 3 over 2. The sine is 1/2. So the coordinates of this point here would be square root of 3 over 2, comma, 1/2. In quadrant 2, the cosine is negative, or our x-coordinate value is negative. So this would be negative square root of 3 over 2, comma, 1/2. In quadrant 3, the coordinates of this point, both the x and y values or coordinates are negative. So negative square root of 3 over 2, comma, negative 1/2. And then in quadrant 4, x value is positive, or the cosine value is positive, square root of 3 over 2, and our y value is negative, negative 1/2. And then I bet you know what the last circle is for, along with the triangles. For a 60-degree angle. Right. For a 60-degree angle here. The point on the unit circle in quadrant 1, whose angle is 60 degrees. Again, it's going to be cosine, sine, 1/2, comma, square root of 3 over 2. In quadrant 2, cosine value is negative, so it's negative 1/2, comma, square root of 3 over 2. In quadrant 3, we have both negative, so negative 1/2, comma, negative square root of 3 over 2. That's a negative. And in quadrant 4, x coordinate is positive, cosine's positive, positive 1/2, and sine is negative, negative square root of 3 over 2. So with enough practice here, you're actually going to memorize these, okay? So let's go to the back, and if we take the large circle in the center and the segment that actually bisects each quadrant, those are our 45-degree angles. Okay, so I'm going to put them in red. So the coordinates of this point would be square root of 2 over 2, comma, square root of 2 over 2. In quadrant 2, negative square root of 2 over 2, comma, square root of 2 over 2. Quadrant 3, negative square root of 2 over 2, negative square root of 2 over 2. Both are negative. And in quadrant 4, square root of 2 over 2, comma, square root of 2 over 2. The y value is negative, so that put the sign in there. Now with the angles of 30-degree measure, all right, I'm going to write these in green. This one here, symmetry over here, here, and here. I'm just taking it from the front, right, for a 30-degree angle. Okay. Square root of 3 over 2, comma, 1/2. In quadrant 2, negative square root of 3 over 2, comma, 1/2. Quadrant 4, both negative. And quadrant 4, positive square root of 3 over 2, comma, negative 1/2. And our last set of 4, I'm using a blue for our 60-degree angles. The coordinates of this point, cosine of 60, sine of 60, 1/2, comma, square root of 3 over 2, negative 1/2, comma, square root of 3 over 2, both negative, negative 1/2, comma, negative square root of 3 over 2. There we go. And positive 1/2, comma, negative square root of 3 over 2. Okay. This concludes tonight's video.